there! We're both Sam, and today we're going to show you an application of math in real life.
The method we chose to be used in a real-life situation is the Gauss-Seidel method, named after mathematicians Carl Friedrich Gauss and Philipp Ludwig von Seidel. Gauss-Seidel method is an iterative method used to solve a system of linear equations. It is also called Liebman's method or the method of successive displacement.
Gauss-Seidel is an improvement of the previously known method called the Jacobi method. The difference between the two is that the Jacobi method is more tedious than Gauss-Seidel's, and it takes a longer time before it converges to a single value. Aside from definitions, we will now show you its application in a real-world problem that involves probability.
Now suppose there is a tourist located at point 1 in the map. There are also 9 other tourists at points P2 to P10 in the same area. Being tourists, they are not familiar with the locations yet, so they go around going to random places.
Now you want to know what is the probability of each tourist arriving at Amsterdam with the random path strolling. To solve this using Gauss-Seidel method, we must first transform the equations into a matrix.
To do this, the tourist at point P1 has 1/4 chances of going over each of the possible paths he will take. Let's assume this map is our only scope and whoever goes out of bounds has no intention of going to Amsterdam.
The tourist at point P1 has 1/4 chance multiplied by 0 if he chooses to go to the left path. It is multiplied by 0 because we assumed there is no chance of them arriving at Amsterdam at this state. He also has another 0 chance if he chooses the northern path.
He does, however, give P2 a chance if he goes down the southern path. He also gives P4 a chance if he chooses to go to the right. In the end, we obtain this equation for P1. Doing the same for the other points in the map, we obtain the following equations. As you can see, some of the paths are multiplied by 1 instead of 0 or a point P. These paths indicate that it leads directly to Amsterdam or the target destination. For example, this 1 in P3 indicates that a path in P3 leads directly to Amsterdam.
Now we rewrite this equation in standard form, which produces a system of 10 linear equations in 10 variables. To transform, we multiply both sides of the equation by the LCD and transpose all terms with constant to the right. The resulting form looks like this. From this form, we then turn it to a matrix which eliminates all variables, leaving only our coefficients.
Now we compute it using Gauss-Seidel's method with this formula. Now don't get surprised by the looks of this. Here's the general idea of how it is used. We go back to our standard form. We can solve for P1 by equating it, so our resulting form will be like this. We suppose all variables, in our case points P, has no values yet. Substituting 0 to all our variables, we get. Now we use this value of P1 to solve for the value of P2. Equating P2, we can substitute the obtained value of P1 in all of P1's occurrences in P2. Other variables, like P3, will be substituted with 0 because we have no value obtained for it yet. Then we use the previous computed values of P1 and P2 to be substituted on all occurrences of these variables in P3, which is 0. Doing the same process over and over again will give us 10 values for our 10 variables. That will be our first iteration. Now using all of these computed values, we solve for P1 again, until we reach P10. After it is finished, that will be our second iteration. The process repeats again and again. The values used in the previous calculations will be used in the next, until we notice that these values converge at one point. If that happens, then we can say that the final value is the value we are looking for. These are the results after 15 iterations.
Looking at this, we can at least say that the tourist at P4 and P5 has the most chances, because they are closest. But P3 doesn't have as much luck as them, even if he has a path that leads directly to Amsterdam.
That's all for now. Can you give other problems that can be solved using Gauss-Seidel method? Let us know. Bye!
Created using Powtoon.